Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 183, the very first problem on page 183. Problem number 214. Okay, make sure you have the book in front of you, read the problem to yourself, and you will see that it says that we are told that reciprocal of R equals the sum of the reciprocals of x and y. One more time, we are told in the problem that reciprocal of R equals the sum of the reciprocals of x and y. Let's see what the problem actually says. It says in an electric circuit, two resistors with resistance x and y are connected in parallel. Whatever that means. Something is coming back to me from many moons ago. In the high school, in the school years, in the physics course we learned these things. Something to do with ohms and all that. I remember it vaguely. In this case, if R is the combined resistance of these two resistors, then the reciprocal of R, there we go, then the reciprocal of R is equal to the sum of the reciprocal of x and y. Sum of the reciprocal of x and y. The question simply is, what is R? What is R? What is R in terms of x and y? So let's find out, shall we? We are told that reciprocal of R equals the sum of the reciprocals of x and y. So here is your reciprocal of x, here is our reciprocal of y, and that's their sum. One more time. The reciprocal of R equals to the sum of the reciprocals of x and y. That's it. You just have to solve for it. So the common denominator of x and y is x times y. Xy divided by x is going to give us our y. Xy divided by y. In other words, here's what's going on here. Here we have 1 over x. Here we have 1 over y. We want to add them, but we can add them because they have different denominators. How do we make the common denominators? How can we make the denominator common? Well, that's very straightforward. Take this fraction and multiply it by y over y. You can do that because y over y is just 1. Similarly, take this fraction and multiply it by x over x. So here we end up with y times 1, which is y, and at the bottom we get y times x is just x times y, plus 1 times x is x, and y times x again is x times y, and there you go. Now they have the same denominator. So it's x times y over y plus x, which is same as x plus y. That's it. That's our answer. That's it. That was 214. So the answer is D. Let's do the next one, shall we? Next problem, 215. We are told that x, y, and z work independently. X, y, and z work independently. We are also told that the odds that x will succeed is one quarter. We are also told that the odds that y will succeed is 1/2. And we are told that the odds that z will succeed is 5/8. The question is, what are the odds? What are the odds that x and y will succeed but not z? In other words, how likely is it that x and y will be successful at solving this problem but not z? Well, let's start from the very beginning, and let's make sure that we understand the terminologies and concept behind it. What do they mean when they say they are working independently? Well, working independently is how statisticians talk. It simply means that the chances that x will succeed or fail has absolutely nothing to do with what y and z are doing. Similarly, the odds of y being successful or failing at something has absolutely nothing to do with what the other two guys are doing. Their probabilities are independent. These events are independent. As we can tell from here, let's erase this part here. You should have some gut feeling before you start the problem. You should have some gut feeling as to where this is going. As you can see, we are told that the odds that x will succeed is only 1/4, only 25%. Odds that y will succeed is 50%, but still, it is less than this guy. Z has the highest probabilities, 5/8. 5/8 is more than half. So as it stands, we are told that z has the highest probability of succeeding at this task. And then they go ahead and ask us anyway, how likely it is that the other two guys will succeed but not z? To which the answer would be, not bloody likely. In other words, the answer is going to be very small. So if you end up, after you do all the work and you end up with some huge number like 3/4 or half or something ridiculous like that, you should know right away that something has gone wrong. The odds are very slim that the two guys with the lower probability will actually succeed and not the guy with the highest probability. Let's do it out, shall we? Let's do it out. Let's do it here. So here's your x, here's our y, and here's our z. Let's start then. What are the odds that x and y will succeed? Well, what are the odds that x will succeed by himself? It's right here. It's 1/4. What are the odds that y will succeed? Well, it's right there. It's half. And finally, what are the odds that z will not succeed? Not z. X yes, y yes, and z no. What are the odds that z will not succeed? Well, the odds that z will succeed is 5/8, 5/8. Therefore, the odds that he will not succeed must be 3/8. And since these are independent events, the way we figure out their probability is by simply multiplying the three numbers. And that's it, we are done. We are done, that's it. 1 times 1 is 1 times 3 is 3/64. That's our answer. As I said before, the odds that the two guys with a lower probability will succeed and not the third guy who we are told in the beginning has the highest odds of succeeding at it is not very likely. Let's do one more, shall we? Let's do one more problem. Let's do one more problem. A new problem. This is how the new problem reads. It says x, y, and z work independently. The odds that x will succeed is 1/4. Odds that y will succeed is 1/2. The odds that z will succeed is 5/8. We haven't changed anything so far. What are the odds that all three of them will muck it up? What are the odds that all three of them will muck it up? The reason I write the word in capital letters is because I want to make sure that you understand muck it up with an M. There's no need to get excited. Not with an F, with an M. And if you don't know what that means, look it up in the dictionary and learn it yourself. What are the odds they will all muck it up? What are the odds that all three of them will make a pig's breakfast of the whole thing? Well, let's find out, shall we? So now we are looking for this thing. What are the odds that x will succeed? What are the odds that x will fail, and y will fail, and z will fail? You have given this problem to three different people in in your organization, in your department, in your business, or 3 different engineers to work on this problem. And based on their experiences, based on their knowledge, based on what you know about them, you have, on your gut feeling, assigned some probability as to how likely the guy is to succeed at this problem. And these are the probabilities that you have assigned. Now, question is, what are the odds that you give them a certain amount of time to work on the problem, and they all 3 of you come back to you a week later saying that I haven't found a solution? Well, let's find out, shall we? The odds that y will not succeed, the odds that y will succeed is 1/4. Therefore, there's a very high chance that he will not succeed, which is 3/4. The odds that y, I meant to say x, not y. So the odds that y will succeed is 50%. Therefore, the odds that y will not succeed is also 50%. And this part we already did here. The odds that z will succeed is 5a. Therefore, the odds that he will not succeed is 3a. That's it. That's your answer. 9 over 64. 9 over 64. Well, that is unreal. That can't be right. Did I do something wrong? 3/4 makes me wonder here. 1/4, 1/2, 3. It is 9 over 64, but how can it be 3 times more likely that none of them will succeed, whereas before we found out that the odds that x and y will succeed, I will have to think about it. I don't want to stand in the camera and just stare at you. I will have to think about it. There must be some logical explanation which I'm not seeing right now. But anyway, that's how you do it. Do you understand? Tomorrow, tell you what, tomorrow we'll do a similar problem. We'll continue with this thing. And tomorrow I will set up a new problem, and I will give it this similar thought too. As to, see, last time with the problem that we just finished, where the question was what are the odds that x and y will succeed but not z, we found out the answer was 3 over 64, which was answer choice, what number is this question? 215. 3 over 64, the answer choice E. 3 over 64. This is 9 over 64, which is 3 times as large. How can the odds that nobody will succeed could be 3 times as more as the odds that at least one guy will succeed? I will have to think about it. We'll give it some thought, as I said. And tomorrow we'll do one more problem similar to this one. Okay? With 2 or 3 parts into it, just to get some more practice. I'll see you tomorrow, okay? Bye now.